So here we are, folks, Module 5, right? We're getting into JavaScript, and there are 7 lectures in JavaScript. So just so I get a rough feel here, how many people have zero experience with programming? And don't be shy, I need to know this. If you don't, that's okay. Okay, so about a third, that's fine, totally good. And then those who do have experience, Java is my assumption, right? Okay, so that was my guess, okay. So there are some advantages and disadvantages to whichever camp you're in. For the new folks, you don't have any paradigms that you have to be confused about. For Java folks, there are some paradigms that I'm going to burst today about your programming knowledge and understanding. If you only know Java, JavaScript is the wild, wild west of programming. We're going to talk about all that, but I want to know what my audience is here, so I know what kind of things to bring up and what kind of things to point out. Also, this book right here called JavaScript in Easy Steps. This book is $10. You can get it at Barnes & Noble, and anytime I learn a new language, like for example, I'm not a Python guy. So I bought the book called Python in Easy Steps. It's $10. And when I first learned MySQL programming, database programming years ago, I bought this book, right? So they're from Barnes & Noble. They produce them, they print them and everything. They're full color. Every page is in color. And what's cool about it is each topic basically takes up one page. These purple headers at the top here, that's just one topic. So this topic right here, that's it. That's the content. Then here is another topic. So it's very easy to navigate. It's a very good book. Not required. You don't have to buy it, but I highly recommend it. All right? So there you go. If you want to learn like PHP or something, get PHP in Easy Steps. If you want to learn CSS better, that's a good, CSS in Easy Steps would probably be a little too elementary for you guys at this point, but they have some really good books in that line of books. All right, anyway, so let's move on to the meat here. This is, what I'm about to tell you is true with all programming languages pretty much, and that is all programming languages are made up of 2 main things, variables and statements. That's pretty much it, okay? Now, statements have a lot of stuff, lots of stuff that are related to statements. And in fact, we as humans, we make statements all the time, don't we? What are some types of statements we make? Like categorize them.
Lies.
Lies? So what is that though?
I was going to say opinions.
So an opinion, yeah, maybe.
True or false?
You might make true or false statements like a declaration. You might declare something, right? You declare a lie, you declare your opinion, right? You could, what's that? Rhetorical statements, maybe? What about like a command like, hey, go do that, right? Go make me a sandwich, right, or whatever. So declarations, commands, we ask questions. A question is not quite a statement, but we're going to fit it into that category of statements, okay? There are other things that we do in the human language that won't fully translate to programming, but in general, in programming statements, there are declarations, there are commands, there are questions, there are functions, which all a function is, and we'll talk more about this a little bit later today, but it's just a whole bunch of statements put together in one little package, okay? And we'll see some use of that in a few minutes, okay? There's also what we call controls. We'll talk about this in a little bit of detail in a few minutes, all right? So the plan today is this. Just like our first day with CSS and maybe our second day with CSS, I want to kind of expose you to a bunch of stuff. On the first day of CSS, we talked about the syntax, we talked about properties and selectors and all this stuff. And then over time, we sort of fine-tuned our knowledge of it and we learned a little bit more in depth. Same thing here. I'm going to throw a whole bunch of stuff at you today, and not all of it's going to stick. And I'm not expecting you to be masters of anything, but in a couple of days, we'll start sort of, honing in and getting a little bit more focused on the material. Okay, so any questions about this basic big picture right here? We feeling okay with this? All right, so next up, what the heck's a variable? You've taken algebra before, you know what a variable is, right? So for example, 7 plus x equals 10. What is x's value? 3. Yeah, it's 3. We know this from our basic days in algebra, okay? So what is a variable? How would you describe it to somebody who'd never heard of it before?
It's a placeholder that has a specific value or an inferred value.
Yeah, it's a placeholder. That's a good way to think of it. It's just a placeholder. Okay, so X is a placeholder for 3 in this particular case. Easy enough. Okay. So when it comes to variables, there are really only 4 things you can put in a variable. There are numbers, there are characters, there are words, and there are objects. And that is it. That is all you can put in a variable. Okay? Let me tell you briefly what an object is, because we're not going to cover that in this class, right? If you've got a Java background, you know exactly what an object is, right? If you don't, all an object is, it's a complicated data type, right? A number is a data type. 1, 2, 3, 4, 7.8, 6.2. Those are all numbers. The data type is a number. Well, an object's data type is, for example, my mouse here. This could be an object, right? It's more than just a simple number 3. It has a color property. It has a weight property. It has what type of mouse is it? Is it wireless mouse or not? It has different properties. So I can create in code, and we're not going to do this in this class, but you can create in code an object that has all of these properties associated with it, and you can store that in a variable called X or whatever, right? So for this class, though, don't worry about objects. Let's look at numbers, though. There are 2 types of numbers. There are integers or whole numbers, right? We know them as whole numbers. In our computing world, they're called integers. And then there are decimal numbers. In our computer world, we call those floating points, okay? Those are the 2 types of numbers. The character is exactly what it sounds like. It's a single character. It can be the letter P, or it can be a 0, or it can be a dash, or a square bracket, or a slash, or an L. It could be just one single something, okay? Words, in our world, we call these strings, because it's just a string of characters strung together, okay? We just put a bunch of characters side by side and you get strings. So, for example, Bob is a string that contains the character B, the character O, and the character B, strung together. All right, so questions about that basic, very basic idea there. Feeling okay with that? We good? All right. Now, here's the first thing that's going to be weird for Java folks. In the Java world, if I'm going to create a variable called X, I have to be explicit and say, hey, this variable is an integer. It's an int. And it's called X, and I'm setting it to the value of 9. Okay? This is Java code. This is not JavaScript. This is Java code. In Java, you have to be explicit and say it's an int, right? If I wanted to make a floating point number, I would have to say float X equals 8.7 or 8.4 or whatever. If I wanted to have a string, I'd have to say string X equals Bob, and so forth. If I wanted a character, I'd say char X equals C, right? Something like that. This is what happens in Java, not what happens in JavaScript. In JavaScript, it doesn't care what the data type is. You don't have to tell it. You just say, hey, I need a variable called X, and it will figure out what data type it is. So if I wanted to create a variable called X that had the value 9 in it, I would literally just type var X equals 9. That's it. Whether it's a string, a float, an int, or whatever, it doesn't matter. So we don't even really care too much about these in our world for this class, okay? It'll come up a couple times down the road, but for now we're fine. So here's a couple interesting things about this var X here. First of all, especially for new folks, this thing that's highlighted here is not called the equal sign, okay? It's called the assignment operator. It's not called the equal sign. This means this whole line of code says, hey, var says, hey, computer, wake up, computer. I need you to block out some memory, call it X, and put the number 9 in it. That's what's going on there, okay? In Java, it says, hey, memory, wake up, block out a very specific amount of memory, the amount that can hold an int, which is assigned in Java, how big that is. Call it X, put the number 9 in it. In our world, we use var, and it assigns however much memory it's going to need, depending on what the value of X is, okay? Later, if I need to change the value of X, no problem. I can just say, okay, now x is equal to 19. Not a big deal. And later, if I want to change the value of x again, I can say x is equal to Beavis. No problem. Can't do that in Java, okay? In Java, you cannot assign a string to something that was once an integer. You cannot do that, yeah.
So once you initialize something as var x, it's in there forever.
Yeah, so the question was, once I do this, I wouldn't say forever, but I know what you mean, yeah. So once you do this, you've initialized it. This line 9 here is initializing the variable. And in fact, to initialize a variable, all you have to do is that. Create a variable called x, right? Later I can assign a value to it. Here I'm just assigning a value. I'm not declaring the memory, right? Which is what's going on in line 9 is where I'm declaring the memory. It just so happens that I combined two steps and I declared the memory and added a value to it. Paradigm number 1 that you'll have to break if you're from the Java world is you can reassign the data type to the same variable anytime you want. So we can, anytime we want, change the value of a variable here, right? If I need to change it, I can do it. And that's a very common thing in programming. You will change a variable's value. We'll learn why later as we go on, okay? Now, I'm about to show something on the screen. Java people are immediately going to have a question. The answer is yes, okay? I promise that the answer is yes, all right? Okay, so it's very common in the programming world that I need to increment a variable, all right? I have a variable that's maybe starts at the value 1, and then I want to increment it to 2, run some code, then increment the variable to 3, run that code again, increment to 4, and keep doing that until I hit the number 10, so that code will run 10 times. We call that a loop, right? That's a very common operation. So the way you increment a variable, I can say x equals x plus 1. Now, if you've never seen programming code before, and this is your first time seeing it, and again, I'm going to show you how to put this into your actual HTML in a minute. But if you've never seen programming code before, and you're from a math background, that makes no sense, right? How can x be equal to itself plus something else? That's impossible, mathematically speaking, which is why I want to remind you that is not the equal sign, okay? That is the assignment operator. So here's what line 10 is doing. Line 10 is saying take the value of x, which is 10 at the moment, right? Add 1 to it, so now it becomes 11, then assign it to x. That's what's going on there. Make sense? So now x's new value is 11. That's its new value after line 10 runs, okay? All right, so other questions about what's going on here? We feeling okay? All right. So we've looked actually at a declaration already. I've declared that variable x is equal to 10, all right? We haven't looked at a question really. I have looked at a command, which is kind of what's going on here. I'm saying I've declared some memory and then I've assigned it a value. So that's a command. I'm not going to test you on these words here. They're just to give us a framework, all right? Let's talk about functions though. Because functions are a group of statements, which include some variables and could have other functions in them and a bunch of stuff. So if you have a math background, you've seen functions that look like this, right? We've seen that before, right? That's just from basic, Algebra 2 probably, right? F of x is equal to 2x plus 1. So what is f of 4? What's that? 9. F of 4 is 9. Does anybody not understand why f of 4 is 9? Okay, this is math. This is not programming. This is math, okay? All right, so f of 4 is 9. Well, here's what's really going on. A function is just a magic box. It's magical. You give it something, it does something, and it gives you something back. That's it. I don't have to know what's inside the function. If I wrote some computer code that did this for me, right here, all I would know is if I give this a 4, it's going to return a 9. That's it. I don't care what the formula is. I don't know how it got there. It doesn't matter, okay? That idea is called encapsulation, where you sort of hide the code from the end user or the end programmer. So this is what's going on here. I had a 4. I handed it off to this magic box called f of x, and it handed me back a 9. That's it. It's a magic box. Think about when you drive a car, right? you can drive a car even if you don't know anything about cars. You don't know how the engine works. You don't know why when I push the long skinny pedal, it makes the car move. You just know that it does, right? Now some people do know that, but you really only have to know a handful of things to drive a car, right? How to turn it on, how to steer, and what the two pedals do. And you got to know the rules of the road, but to actually just make the car move and turn, you don't have to know a whole lot. Okay, it takes practice, but you don't have to be a mechanical engineer to do that. Same thing here. The idea of a function is you hand it some data and it does something with it and it hands you some results. It returns a value. Well, in programming, there are functions that come with every language, that most languages have functions that are built in, and then you can also write your own functions, okay? So we're gonna look at a built-in JavaScript function, which is pretty much not very useful anymore, but it's just a good way to start down the path to understanding this stuff. So the function is called alert. And this is how I call it. I type the word alert, the end. Now, if I want to pass in some parameter, like I have an X down here, you could look at this like saying alert of X, right? So whatever X is, I'm passing X to the alert function. X is going to happen, something's going to happen to X in the alert function, and then some output's going to occur, right? Well, in this particular case, the output of alert is a little pop-up box on your screen, right? So if I said, hi there, if I ran that line of code, a little pop-up box will appear on my screen that says, hi there. Let's put that to the test, okay? How do we add code to our HTML? Right here. In the head section, for now, we'll talk about other ways later. Remember back in the day, we had this, we had style, right? And we had, P and then background color is pink or whatever, right? What does that mean? On line 6 and line 8, it means, hey, browser, the stuff between 6 and 8, it's not HTML. Ignore it and run it like CSS. So don't treat it like HTML. Well, there's the same thing for JavaScript. And it is the script tag right here. And I can place that alert right inside of the script tag, and it does the same thing. It says, hey, browser, ignore the stuff between line 6 and 8 as far as HTML is concerned. Treat it like code. It's actually JavaScript code, okay? So now if I run this page right here, I get a little pop-up box that says, hi there, okay? Now, real quick little thing here. If I open this up and say Firefox, we get, that's our pop-up box. It looks totally different, right? Stand by while I control my nausea as I'm about to open up Edge. And we get this, okay? All right, it's gonna get even more nauseating here. So open Internet Explorer. Oh, I know. I'm afraid to. Netscape? Oh my gosh. Surprised you even know about that. I'm trying to click on there. See, I clicked like 20 minutes ago.
Is Edge your least favorite browser?
Edge, probably Internet Explorer is worse because watch what happens when I do this. It blocks the pop-up, right? So I can say allow blocked content, and then listen. You get a little bell, and you get this little warning symbol, and you get a pop-up in the middle, and I cannot close the page until I deal with this. Really annoying, right? So every browser renders it differently, right? Let's look at Opera. I like Opera. I'm actually considering switching to Opera. I don't know enough about their dev tools, though, to make the full decision yet, because I'm getting a little burned out on Chrome. There's some quirky things that are bugging me about Chrome. But that's the pop-up on Opera, right? It's the page says, hi there, okay? So they all look different. Just like when we first learned about HTML, an H1 in one browser looks different than an H1 in a different browser, right? And that's why we have CSS. We can override all that. Well, with JavaScript, you can't really override the pop-up box. The pop-up box is not, we're not going to use that other than your first 1 or 2 assignments just to get your feet wet. In the real world, what do we really want to do? We want to display your HTML using JavaScript right here on your page. So we want to be able to change what's on the screen. So click a button and your whole web page changes based on the button they clicked or whatever. That's what we want to get to eventually. We want to learn how to write to your HTML dynamically, right? Okay, so go back to this now. We have this simple alert here. Hi there. All right. Or better, happy birthday. Java people, this is your Hello World program. What is a Hello World program? Since the 70s, whenever you learn a new programming language, the first task you do, just to sort of wrap your head around how to compile the language or how to interpret it or how to run it or what's the syntax, you write a program that spits out Hello World. It's like the program, it's being born, and it's just, you're welcoming it to the world, right? So the program's saying, hello world, here I am, I'm born. So I prefer, instead of saying hello world, I say happy birthday. Fake bonus points if you get the reference. Why do I use happy birthday?
Is it a reference to Frosty the Snowman?
It is a reference to Frosty the Snowman.
Happy birthday!
Your very first homework assignment for JavaScript is the happy birthday program, right? Now, we're going to get a little bit more involved than just this here. I want this to be able to take in the user's name, and I want it to say happy birthday, whatever the person's name is, right? So let's start with another function. It's a built-in JavaScript function called prompt. And I'm going to pass in a parameter, just like the parameter here was happy birthday. The parameter here is going to say enter your name or something like that. Now when I run this program, it says enter your name, a little pop-up. Now again, in the real world, this is not how we want to get input. We're going to have like a web form on your screen where you can enter it and then JavaScript can process it. But for your first program, you're going to do it this way because it's easy and just get your feet wet, right? So enter my name, Beavis, or Beavsai. It's my nickname, I guess. And then it says happy birthday. It doesn't say happy birthday Beavis because we haven't told it to yet, right? But we now have taken input from the user. It's nowhere. We didn't do anything with it, but it did happen, okay? So I want to get my hands on Beavis or whatever name I put in there. How do I get my hands on that?
This is a guess, but do you like say x is equal to prompt?
Yeah, exactly right. You're going to create a variable. So var x or whatever, we're going to call our variable username equals prompt. And so when I run this, what will happen, and even those who have a Java background, listen closely to this because a lot of people don't understand this, even that have a lot of programming experience. This function right here, there's some code. The people who created JavaScript wrote this function called prompt. I have no idea what the code looks like inside of it. All I know is if I give it something, it'll spit that out in the prompt. Well, when I enter a name, Beavis, that literally gets replaced with Beavis, in quotes. I didn't put the quotes there, but that literally gets replaced with Beavis. It's wiped out and just Beavis is there. And so now all I'm saying basically is var username equals Beavis or Jeff or whatever name I put in there, right? Okay, so if I run this again and I say my name is Butthead, it still doesn't say happy birthday Butthead because we haven't told it to yet. But now there is a variable called username that is holding the value Butthead, and I can prove it to you, okay? So if I right-click, go to Inspect, go to the console, and I type in the name of that variable, which was username, it tells me its value right there, Butthead. So if I run it again, Daria, and I type username, it tells me that the value is Daria, right? So we are capturing the value. Now I just wanted to say, happy birthday, Daria, or happy birthday, whatever, right? So let's start baby steps. Notice that here, I can simply put username, or user jam, whatever, right? Username, I can put that, and what's my pop-up box gonna say? Whatever name I typed in, right? Type in Stuart, and it says Stuart, because that's stored in that variable called username. Well, I want to put the two together. Happy birthday, Stuart, okay? And those who have the Java background, how do we do something like that usually?
In quotes, happy birthday, and then plus username.
Yeah, it's called the concatenation operator, which is just a plus sign, right? So it's happy birthday, plus username. That's concatenation, right? Concatenation is just a fancy word for sticking a couple things together. You can concatenate as many things as you want. In fact, let's just add an exclamation point at the end here, like so, okay? So happy birthday, space, because if I don't put the space, then Beavis will be crammed right up against the Y of happy birthday, plus name, plus exclamation point. That gives us what we're looking for. Let's close the console here, refresh, and Mr. Anderson. See, that's not a Matrix reference. You guys think it is, but it's not.
Mr. Anderson.
That's a Beavis and Butthead reference. So now, but look what it says, happy birthday, Mr. Anderson, right? What happened there? I grabbed the name Mr. Anderson. It became assigned to that variable. Then I said, print out happy birthday, plus the username, plus an exclamation point, and we get happy birthday, Mr. Anderson. Your happy birthday program that's almost the entire program right there. I've written about half of it for you, okay? The rest of it, I'll let you read the instructions, but the rest of it, it's saying also get an age from the user. And then in your alert output, display some message that uses their name and their age, right? So a simple version of that, please enter your name, Beavis, please enter your age, 12. Happy birthday, Beavis, you're 12 years old, right? That's what we're looking for. So I'm not gonna do it because you guys need to do that for your homework assignment, but how would I get the age? Yeah, just another prompt, right? Just prompt, age, call it whatever you want, enter your age or something like that. That works just fine. And then you are, I said I wasn't gonna do it, then here I am doing it. You are age, years old. There, I just did your homework assignment for you guys. That's it. That's really all there is to it. Now, look in the rubric, because there's a couple extra things. There's always the additional content, right, and all that stuff. But that's the basic idea of the program. I mean, that's it. Doing that, just get your head around the basics of writing some JavaScript code, okay? Feeling all right? Okay? Now, just like in CSS, this style here, if we were writing CSS, can get pretty unwieldy, right? Well, same with your script. JavaScript code can get pretty huge. And the last thing I want is my HTML filled up with a bunch of JavaScript. So we pull it out into a separate file, just like we do with our CSS. So I'm going to open a new file here. And I want to put only the JavaScript code, right? Not the script tags, because the script tag is HTML. So I'm going to move that JavaScript code into here. Save it. And I'm saving it into the JS folder, which all of you guys should be making those in your projects. Call it whatever you want, okay? I usually call mine script.js, but let's go with Beavis.js just to prove it can be whatever you want. But it has to be .js for JavaScript, okay? So there we go. Now you get your syntax highlighting. That looks good. Now how do I refer to it in my HTML? You actually use the script tag. And you use the source property, and you just put the file path. So JavaScript and Beavis.js. That's it. So now if I run it, we should have still the exact same program. And so what's your name? Bob. How old are you? 33. Happy birthday, Bob. You're 33 years old. That's the happy birthday program, right? It's pretty straightforward. Okay, questions about big picture. How are we feeling? Especially new folks. I don't remember who you are, so I'll just let you guys tell me if you're doing okay. And I won't keep singling out any of the people that don't have a background, because I just want to see where my audience was, yeah. Sure. Yeah, so all you do, so this is a little different. With the link tag, you have all these different attributes, right? These 3 attributes you have to refer to, and there's no closing tag. Whereas the source, the script actually has the closing tag, and it's just using the source property. Now, the reason this has a closing tag is because you could put code in there, right? Whereas link, there's no such thing as this. You never put code in between here. What they should have done is made style like they made script, right? Something so that's similar, but they have a separate thing for style where you want to hand code the style, and they have a separate thing for linking. So strange, but anyway, the way we do it here for script is like so. Okay, and you can have multiple script files just like you can have multiple HTML or CSS files, right? I can have style 1 and style 2, no problem. I could have, script and liver, whatever. I can have, whatever. Just making up words here. Okay, you can have as many of them as you want. All right, so let's back up here. In fact, a lot of times if you're writing a web-based program, you may have multiple JavaScript files embedded, and your HTML is nothing but JavaScript files. Like there's nothing in the body or anything. It's all line 6 and just a whole bunch of scripts, and then it generates the HTML on the fly. Right? That's a very common thing if you're doing a web program. All right, we good? Okay, phase 2. Let's take a look at our little notes here. What a function, we have not written a function. We may have time to write one today. But a function is just, if I were to look at the raw code of this alert function that we don't have, it's somewhere in the Java documentation probably, or JavaScript documentation, it would be lines and lines and lines of code, right? That somehow magically puts a pop-up box in your window, right? Well, we're going to look at controls next. We got functions as a basic idea. It's a magic box, and there's some hidden code we can't see. Later we'll create our own, right? But what about a control? Let's talk about that. There are two main types here that we care about for now: loops and branches. Okay. For loops, for branches, we're gonna look at that today. We have the if and the switch. Okay. Switch comes another day. If is today. All right. We're gonna look at the if statement today. If statements have a lot of components to them, so we're gonna break this down in some pretty easy steps here. Let's go to our JavaScript file. I'm gonna kill this, and I'm going to say enter food. And I'm going to change my variable name to food because it makes more sense. We're going to write a program that will either eat the food we feed it, or it will not eat the food. So give me 3 foods that the program eats.
Sushi. Broccoli.
Sushi, that was the first thing named this morning's class, was sushi. That's strange.
Fish.
Curry,
Ravioli.
ravioli, that's good. All right, so those are the 3 foods that our program will eat. That's it. It will starve if it doesn't eat. If you try to feed it a hamburger or something, right? So first of all, we have a variable called food that we are going to type in some food, and the program will have access to this food. We're going to ask it a question. We're going to say, if food is equal to sushi. Now, Java programmers, you're going to cringe a little bit with the next few lines of code I write, okay? Don't panic. You're going to have a whole bunch of questions like, well, what about doing it this way? What about doing it that way? Yes, 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 and yes, right? Just stand by. We got to do this in baby steps, right? But yeah, there's plenty of things that you're going to see that are not very efficient code. So here's to your question earlier about lack of efficient code. I'm going to show you some inefficient code just to give you the basic foundation here, okay? So I'm asking the question here, if food is equal to sushi. Now note the use of the double equal sign here, okay? This is not the equal sign. This is not the equal sign. This top one is called the assignment operator. The second one is called the comparison operator. This is me comparing, I just made up a word. This is me comparing food to sushi. I'm asking you, is food equal to the value sushi? It's a question. Is it or isn't it? Well, it depends on what I type, right? Okay. This phrase here will evaluate to either true or false, one of the two, okay? When all is said and done. Either it will be sushi or it will not. There is no other option, okay? If it is sushi, I'm going to do a little alert box there that says yummy, something like that, right? That's it. That's the beginning of my program, right? We'll deal with curry and ravioli in a minute, but let's run this and see what happens. So I'm going to type in chicken, and nothing happens, right? But if I type in sushi, it says yummy, right? Because this evaluated to true when I typed in sushi, okay? But I have a couple other ones here, right? Now here's where the Java folks are gonna get a little nervous, okay? Stand by. So I'm gonna say if it's curry or ravioli. Should I spell that right? I'm changing that word too. I can't, I know how to spell it, but I can't type it. So duck, right? Okay. So this program will now work. There's some issues with it, but it will actually work the way we want it to. So let's run it. Watch what happens. All right, let me make sure I'm fully refreshed here. So get out of here, refresh. All right, so I'm going to enter not one of those three. Nothing happens. I'll enter duck, says yummy. I'll enter sushi, says yummy, and I'll enter curry, and it says yummy. Anything else, nothing will happen, all right? So we could say we're done, right? But let's make sure that we have this a little bit more clean and clear, all right? By the way, notice here, these little slash marks. These are what are called comments, okay? Comments are used to write notes to yourself as the programmer. So this is a note that the browser doesn't see, doesn't care about, it ignores it. It's just a note for me. So you might have some complex notes in here like, this is the section that determines, you know, whatever, if the food is edible or whatever, right? Just make your note. Okay, we're gonna get rid of that though. Okay. Now, there's a problem though that's happening here. If I type in sushi, this will evaluate to true, it'll print out alert, it'll alert out yummy. But then it will immediately run line 7 and ask if it's curry. Well, why do we want to ask if it's curry? We know that it's not, we know that it's sushi. So now that's gonna run, and then after we determine it wasn't curry, because it was sushi, this one's gonna run. Well, we know it's not duck because it's sushi. So that's inefficient, right? So, there's a couple things we can do here. If statements have multiple components that they can have. There's if, but there's also if and else together. And there's also if, else if, okay? So let's put that in action here, okay? I can say this, if it's sushi, do that. Else, if it's curry, do that. Else, if it's duck, do that. The difference between adding the else and not having the else is simple. If it decides that it is sushi, it stops. It runs this line here and then it does not check again. It's done. It doesn't run lines 9 through 16. Okay, so that's more efficient, right? This is like saying, all right, is it sushi? No. Okay, then is it curry? No. Okay, then is it duck? It's like a little guessing game, right? Then we have the last one we can do if we want to, just plain old else, no condition, alert, I guess I'll die of starvation. Sad face. Right? So if I type in anything else besides one of those three things, then I'll get the alert, I will die of starvation. So again, how does this work? It goes, if it's sushi, do that. If it's not, okay, well, is it that? Then do this. Oh, if it's not, then is it that? Then do this. Oh, if it's not any of those, okay, then just do this for whatever you entered. Because I won't eat it. I'll only eat those three things, right? So refresh it, and we'll put that in, and I guess I'll die of starvation. Okay? Now, again, Java people, I know there's lots of questions you're thinking about right now, dealing with logical operators and stuff. We'll get to those, I promise. But how do we feel overall about this big picture? Yeah.
I have a question about the comments. Is there like a closing?
Oh, yeah, so the question was, do you have a closing thing for comments? There are two types of comments. There are what's called single line comments, which is what you're looking at right now. And then there's multiple line comments that start like this. A slash, the one on your question mark, then the asterisk, and then whatever your comment is, as many lines as you need, and then you close it with an asterisk and then the slash again. So you can have multiple lines or single lines.
And then also
it loads in the order that you have it placed. So the question was, does the JavaScript load before the CSS? In this case, no, because I have the CSS here first.
So
It's literally the order, it runs this file in order.
when you do the alert box, it pops up before the blue background does.
Yeah, so let me show you what's going on there. So if I refresh this and I say enter a food, what he's talking, let me put a real food, sushi. What he's talking about is my style is not being applied right now. It's there, it's loaded, it's just not being run. It's actually loaded, it pulls it down, because this is coming from the server, right, ultimately. And so, yeah, the CSS file is there, it's just not being run because this program's waiting for some response, okay? And then once it gets a response, then it'll go ahead and apply the CSS, right? Yeah, yeah.
Is that because the JavaScript tag is called before any of the body tags are?
Yes, that's exactly why. Because, so what's going on here, this is trying to style my stuff in my body tag. In fact, the only line of code in there is, nope, that's not it. This one, my CSS file. The only thing I'm doing is styling the body. Well, the problem with that is, when I'm here, yeah, I've loaded the CSS, but my script is running first, and there is no body tag. This has not even been completed yet. So the web page hasn't even been built yet. So there is no body tag for me to apply my CSS to, right? Once I finish this, whatever this code is, which is all right here, then it'll finish building the rest of the page, and then it'll apply the CSS to it, right? All right, other questions? Good? So this program here, a little simple, silly thing. Let's do some more to make it a little bit better though. But we feel okay about the basic idea? This is a control structure. Now, when it comes to if statements, the only thing that's required is an if statement. You don't actually have to have an else. You don't have to have an else if, okay? You have to have an if though if you're gonna do an if statement. Obviously, it's an if statement, right? Okay? You have to have that. You can have else ifs without an else. You can have an else without an else if. In fact, what this program would do is if I don't type in sushi, I'll starve. That's what that is. If they don't type sushi, then it's gonna say I'm starving, okay? All right, now let's make this a little bit more efficient. We're gonna learn, again, I'm throwing a bunch of stuff at you. Not all of it's gonna stick. We'll learn more later. But there is, notice we have some repeat code here, right? Alert, yummy, alert, yummy. It's the same thing over and over again, right? Well, you can, on one if statement, check that it's either that or that or that, all in one if statement, right? And it looks like, now what I'm about to write is not real code, so if you're copying the code, don't type this. But the idea is this, or food is equal to curry, or food is equal to duck, okay? That's not real code, but stand by. When I make it real code in a minute, it narrows it down to look like that. Very simple. In the programming world, instead of the word or, we use this symbol. It's the pipe symbol that's above your enter key. Two of those. That means or, okay? So if food is equal to sushi, or food is equal to curry, or food is equal to duck, the extra one there, the correct one there, I should say, then alert yummy. Otherwise, do this. This will work just fine. So if we run it, refresh the page, we type in sushi, works great. Let's run it again. Let's type chicken, which is not on the list. It says I'll die of starvation. And let's do one more with duck. And it works just fine, okay? Now I'm gonna throw one more thing at you. And a lot of Java folks don't necessarily know this either. When you're dealing with an if statement, first of all, just like our CSS, we have these curly braces here, right? Everything in JavaScript, you're gonna see that when you have a bunch of lines of code that are working together, you use curly braces around them. However, if the inside of your if statement is only one line of code, you don't even need the curly braces. And that's true in pretty much any language that uses curly braces. So this is actually valid code, right? And in fact, if I were writing this program, this is exactly how I would write it. Like that. That's how I would write it. That annoys people, but that's how I would write it, okay? That's totally valid, totally legitimate, and I'll just prove that real quick. We'll run it, and we'll put in curry, yummy. Put in something else, and I'll starve, right? I want to back up and leave the curly braces though, just so that we have a little bit of clarity, all right? So what questions do we have about this? Doing okay? All right, so that's a basic if statement. Back over here to our little notes. That's an if, that's a branch. Let's talk about loops for a minute. Now, there are several types of loops here. The two we're going to care about, there's a while loop and a for loop. There are other types, right? But we're going to just focus on those, all right? So, if I want to run a piece of code multiple times, this is how you do it. So I'm going to comment this whole thing out here so it doesn't run anymore. And I'm going to comment that out as well. So now none of this code will run. It's just being ignored by the interpreter. Here's the syntax for a while loop. This is just the syntax, is not actually the proper code per se, but we use the keyword while. Some condition is true. Do this stuff. That's a while loop, okay? So you put some condition here, while whatever is in there is true, you're gonna run this code right here, whatever's on line 14. So a simple example is this. While x is greater than, while x is less than 3, okay? So let's create a variable called x, var x is equal to 0. And then in here, I'm going to say alert x. That's it. At the end of that, I'm going to say x is equal to x plus 1. So here's what will happen. I'll create a variable called x, assign it the value 0, and then this thing will run right here. It'll say, well, while x is less than 3, do whatever's in here. Well, is x less than 3 at the moment? Totally. 0 is less than 3. So then spit out the number of x, which is 0 at the moment, and then increment x by 1. Change x to the number 1. And then this loop will run again because it's going to check, is x less than 3? Yeah, x is 1 at the moment. That's less than 3. Run it again. It'll alert out 2, or 1, and then 2, then 3. And then it'll stop when it gets to x not being less than 3. So let's clear this out. Refresh. And now it's saying 0, 1, 2, and then it stops. Why didn't it print 3?
Because 3 is not less than 3.
Right, because what happened, after it printed 2, it incremented x to equal 3. And then it asked the question, is x less than 3? Well, no, it wasn't. It was 3 is not less than 3, so it stopped. Okay? That's a simple while loop. Make sense? Especially new folks. How we feel about a while loop? Good? Okay, let's look at a for loop. For loops are very useful for looping through arrays, which we haven't learned yet, but we will learn that in a couple days. So let's start with that, okay? A for loop has this syntax. Let's just comment this out here. Now notice what we had to do to pull this off. We had to create a variable and initialize it to 0. We had to check to see if it was less than some parameter, and then we had to increment it, right? For loop does the same thing, but all in one line of code. So a for loop goes like this. For x equals 0, so we initialize it. While x is less than 3, increment x. Like so. All in one line. Okay? Now I can do the same thing. Alert x. And it'll print out 0, 1, 2, just like before. This is much more streamlined, and also our little rule of thumb where you don't need curly braces if you have only one line of code also applies. This is true in Java and JavaScript as well. Okay? So let's run it, and we should get that same result. 0, 1, 2, done. okay, for loop. Feeling okay on that? And yes, those who are familiar with Java, you can do that the way you do it in Java, right there. Just for those who are new, I'm just doing it that way. Okay, we'll change that later. Okay? By the way, it's tradition in the world of programming these days to use I for this variable. It doesn't matter. I can use a variable that's called duck liver, right? I can call it whatever I want, okay? But we typically use I because that stands for incrementer. This is a counter that's incrementing, right? But it doesn't matter what you use, okay? How we feel about that? Doing okay? So what could we do to combine the two of these things? This idea of the branch there with the, I guess I'll die of starvation thing, and a loop.
Could add another variable, maybe like input, and if it equals 0 or 1, like you could ask the user at the end, like keep going, see what.
Yeah, we can run the program as many times until the user decides to manually break out of it, right? By taking some other input in or something like that. So let's play around with a couple of these ideas. Let's go back to this program right here, and let's do this. All right, and let's move this loop out of the way here for now. So we're gonna run into a couple little quirky things here, and we may have to do a little bit of debugging and troubleshooting. If you get a little bit lost in the shuffle, don't panic, because this is just, we have some extra time, so I wanna throw this out. That's the only reason we're doing this, okay? So, first of all, I want to get a prompt from the user like we're doing right now. But I don't want to recreate the food variable every time we loop. So I don't want the var food to be inside the loop, because then I'm reallocating the memory every time. Every time the while loop runs, I'm saying var food. Well, I don't want to just keep opening up a block of memory called food, right? So we're going to just start with creating a variable called food outside of our loop. And then inside of the loop, we'll assign it a value, right? So our loop is going to be here. While something, do this. Okay? While something, do this. All right, what's the something? Some input from the user, right? Okay? Well, we also want to do this inside of our loop. Right, so I want to have a loop. So we haven't figured out what the while exactly is. It's going to be some user input, but we don't know exactly what yet. But here's the idea. While some condition is true, I don't know what that condition is yet, get a value from the user, and then if it's one of these three values, go ahead and say yummy. And if it's not one of those things, then say that. And then when you're done, we are going to break out of the loop, right? Okay. First of all, let's decide what we want to use for them to break out. What about maybe the word exit? If they type in exit for instead of a food, they'll break out of the loop. Okay, so I need to look for if they typed in the word exit, right? So if it's one of these things, then alert yummy, right? I can just say, well, food is not, that's what that little exclamation point equal to exit. While food is not exit, do everything in the loop. That's it. And it'll loop forever until somebody types in exit. Here we go. You ready? Enter a food. This is good. Chicken. I guess I'll die of starvation. I hit enter. Enter a food. Sushi. Yummy. Enter a food. Exit. I guess I'll start, but now it does exit out. So we need to deal with that. What's the way to deal with that? We don't want this line to run when they type exit. Why did this run? Those who don't have a background, why did this run?
Because it's not one of those.
Because it wasn't sushi, curry, or duck, right?
Yeah.
So what can we do here? Well, we can actually turn this into an if statement, an else if, and say else if food not equal to exit. Yeah, that's the else if would prevent that from happening, right? So yeah, once it runs this, if it finds the right food, this gets skipped entirely. The loop will continue because they didn't type exit. But if they did type exit, then this line will it'll not run this. They type in exit, that will not run. It'll get down to here and say, is it not equal to exit? Well, it is equal to exit, so this will not run. And then the loop will check up here, is it not equal to exit here? It's it is equal to exit, so it's gonna exit out of the loop, right? Right? So enter a food, let's go with sushi, yummy, hen, I'll die, exit, and it leaves, okay? Now, we could spruce it up a little bit, right? What could I do? I could say, if it's actually equal to exit, alert, goodbye. You have to be able to spell to be a programmer too, right? And then else, do that, right? So if it's one of these three foods, print yummy. If it's exit, print that. If it's anything else, print I'll die of starvation. Now we get some feedback to the user, letting them know that we're done. Fresh, sushi, curry, whatever, exit. Goodbye. Okay? All with a little loop here. Now, you want to mess with people, you don't need any of these curly braces here, which is how I like it. Because there's only one line for each of those, right? And I would, again, move this up to this line here. Here's the crazy part. If this variable weren't here, I wouldn't even need the curly braces on my while loop. Because it's one line. This is actually technically one line of code. But I've got two lines of code because I have food and this. Okay? But this is good. I'm okay with this. Questions? How are we feeling?